what I was getting at was that surface area is the outside of the shape versus volume is how much would fit inside the shape. So picture volume being like how much liquid is inside your water bottle, or how much Kleenex can we fit inside this box versus a smaller Kleenex box. So volume is how much we can fill up inside. So the first one they talk about here, this volume, is just talking about the volume of the puzzle piece. And puzzle piece is this little piece here that we have. And they don't give us a formula. They want us to realize it's just the number of cubes. So we're basically counting the cubes in this case. Kind of like when we had to count faces or edges. Now you can assume that if you think it's supposed to be there, like there's not going to be like a hidden missing cube on the back side. So being able to kind of figure that out as we go. So if everybody kind of wants to count quietly to themselves, I might break it into chunks, I think, here. Did you get 37? I think I got 37. And so my logic with is I broke it into like 3 different parts. So I like looked at this first part here. There was 6 on the top and there's 4 rows of 6, so there's 24. This next one, there's only 1 row, but it's 4 down, so I counted those 4. And then this one, it's 2 by 4, which is 8, but then there's this extra one, so I just put a 9 there. And then I just added those up. So this would be 37 cubic blocks. Now, volume is going to be measured in units cubed because it's 3-dimensional. So there's not a way for me to hold, like, especially when you picture like a liquid, a lot of times volume is a liquid. I can't like hold like a gallon of water in my hands. I need like a vessel to put it in. That's kind of the idea that cubic, it has that extra dimension to it. So, we're going to talk about those formulas. So again, the volume is the amount contained in a 3D shape. So picturing like Zippy's tank, like filling it up with water and how big it is and how depending on, like, if we had a smaller tank, obviously Zippy would be smaller in there, or like would be more crowded, but there'd be less water in there as well. So that volume matters a lot. We're going to use, we've used this before, the capital B. Again, that's still the area of the base. And we're going to talk about 2 formulas today. We're going to do prisms and cylinders. Tomorrow we'll do the cones and pyramids. So our volume of our prism. So again, going back to our prism, remember our prism is parallel bases. Kind of the idea of it usually looks like some sort of cube or a dice, even if it has some different weird shapes to it. So our formula for our volume of our prism is capital B times H. Remember, it's units to the 3rd power, and because this is the area of the base. And then obviously h is the height of the prism. Now that means then we have to know what the base is. So we have to use the formula So I can't tell you for sure what the area formula is going to be because I don't know what the shape is going to be. We've learned that the base could be a pentagon, it could be a square, it could be a triangle. So it depends on what type of base we have for our prism. Whereas a cylinder is a little more straightforward because a cylinder, the base is always going to be a circle. So when I say this is my formula, the base is a circle for our cylinder, so we're going to do pi r squared. So if you'd rather write the formula this way, that's perfectly fine with me, pi r squared h. Because every cylinder is going to have that same formula. And obviously h is the height of the cylinder, still units cubed. So we'll go to the back side where we actually get into these these volumes, and then we'll do one where we have to find a missing piece of the information. I actually think volumes are easier than surface areas, so like a lot of times it doesn't happen in our class where the chapter gets easier as we go ahead. All right, so we have this cylinder here. Now, obviously, it's not going to be as straightforward as we'd like. So we're doing our volume is pi r squared h. So r we'll figure out. They tell us all the way across is 11. So that means r would be 5.5. So they're giving us the diameter is 11. Now the height is over here, and I'm going to define that, but they give me the diagonal across the center of the cylinder there. Now careful, that's a right angle, so the 14 is my C. I found my h. And so then we're going to put this all into our volume formula. And again, if you want to be a little more accurate, you could also work your way backwards. You could leave that 8.66025, that long thing in our calculator, and then we can just multiply it by 5.5 squared, and then times pi. And then remember, this is going to be inches cubed. And you'll notice if you did a little bit of rounding, you guys would get like 822.98, so 99. You're going to realize you're super close, but it's like different enough that it might kind of throw you off. So it might not be a bad idea, again, to leave this answer as our exact answer. Questions there? All right, so that's our volume of our cylinder, but again, be careful with the inches cubed, and that's going to be important in this chapter. I will take off again if you have the wrong units because it is important. We're talking about cubic measurements now. Our next one is our volume of our regular prism. So this is an example where our volume, our area of our base, is a little bit more complicated. So the base is a pentagon. But they tell us it's a regular pentagon, even though it doesn't exactly look like maybe it's all equal. They're telling us it is, so we have to trust that. They're giving us 3.4, and then they're giving us a side length. So they've given us all the pieces we need. So little a is 3.4, n is the number of sides, which is 5. And then S is the side length, which is 5 millimeters. So we're able to find that area just based off the information they already gave us. So capital B is 42.5 for the area of that base. And the height of our prism is 8. And again, that'll be millimeters cubed. Questions there at all? All right, so what we're finishing up with is they have this little block of cheese. This is actually one from our homework that it's an even from our homework, so I just stole their picture there. They say find the length x if the volume of the cheese is 45 centimeters cubed. So the idea with this, though, you have to think about the fact that this is a prism. So we have to think about what our base is. So technically the base is what shape? The base needs to be a triangle in this case. The reason it can't be a rectangle is because remember bases are always parallel. And so the parallel bases will be like the top of that slice. So the cheese is kind of positioned in a way that it's not set on its base. So the base of the triangle, or the base is this triangle, where they tell me 5 and 9. But if we want the height of this triangle, I don't currently know that. So I'm going to have to find the height of our triangle. So down the middle here, I'm going to draw this. So base times height divided by 2, I have to figure this out. I should probably not use x though, because that's what we're looking for. So I'm going to call it y, because this is not going to be our answer. So I need to do Pythagorean theorem. And the 2.5 comes from the fact that we're cutting this isosceles triangle in half. So we have some algebra here to do along with Pythagorean theorem. Square root, and I find out y is 8.86. That's going to be the height of that triangle. So if I do base times height divided by 2, I'm going to take this 8.6 or 8.86, multiply it by the base, which is 5, and divide it in half. So my base is 22.15. Now, they told me the volume is 45. So 45 equals 22.15 times h, and we're trying to figure out h. And I find out h is like 2.03 depending on your rounding, and that'll be centimeters. So definitely a tougher question there, not quite maybe as straightforward as you wanted it to be. Yeah, sorry.
Sorry, I was just confused because we were doing the Pythagorean theorem, we subtracted 2.5 from 81, not 6.25.
Did I? Sorry.
81 minus 2.5 is 7.5, but if you did it minus 6.25.
Oh, you're right. Sorry. So my y ends up being wrong. Yikes. Sorry, we'll fix that. Thank you. Good call. Me going too fast. Thank you for checking.
I was gonna say your base looked wrong, and I was like, wait, that doesn't.
No, because I was like doing it and I was like, wait, am I wrong or what's going on?
No, that's okay. Thank you for checking. So, I mean, we're close, but yeah, it's obviously.
based off that whole, it's 20.
So like 8.6. Thank you. So many steps and easy to make mistakes, but again, it helps when we kind of show our work so we can kind of figure out where we went wrong, if we went wrong. Again, I'm gonna leave this long decimal in my calculator, multiply by 5, cut it in half. So 21.6. So I'll divide 45 by that. I got 2.08 centimeters instead. Hopefully that worked. Thank you, good call. All right.